Okay. So the physical AI is a newly coined term. Agree. But before that, if we see the journey of the AI, we started with the perception, like convolutional neural network. Then we went ahead and brought the generative AI era. Like from the deep learning era, we jumped into the generative AI era. Then currently we are at the agentic AI era, where we are trying to build a lot of agents, uh, which has the potential to automate each and every task, mundane task that we are currently doing. The next wave of industrial digitalization is something our CEO Jensen expects it to be physical AI. What he means by physical AI are two kind of systems where we build inside out AI and outside in AI for robotics. So what does these two terms mean? Exactly, inside out AI is something like from simulation to reality. So when we say any kind of autonomous systems, even a autonomous vehicle like a car, autonomous car is also a robot. So all those vehicles are also robotic solutions. So we can term them as a physical AI aspect. So we believe that all these autonomous vehicles, robots are born in simulation. So we make them like teach reinforcement learning policies, tasks to navigate them in real world so that they don't crash out, because robotic solutions with servos and all these things cost around 40-50 lakhs, can go higher, and we don't want them to crash. So that's why all the simulations we perform at NVIDIA, my current role involves simulating all those physical AI aspects, or like physical aspects, the spatial aspects of all the warehouse, suppose city, drone mapping, all those things. So I need to simulate all these environments, bring into the digital space in our computer, and then train these robots to navigate uh, 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 in that virtual world. Once they learn walking or moving in navigating in this virtual world, then we train these models, AI models. These are basically foundation models for physical AI, foundation models for robots. So these models are being trained and then deployed into a third computer called the Jetson Edge. So at the edge, we deployment of these policies will make them run out of the box. Like so, currently our focus is on solving the generalizable solutions. Like if we want to, so just like AI, if a model is trained, it can be deployed in any kind of compute, and the model will work according to whatever the training parameters are. But not some similar thing is not yet possible in robotics and the physical AI, because the servos, the mechanical parts, actuators, everything is different. So hence we have to be careful on this generalizable aspects. So what we coin this term as cross-embodiment. So we are trying to yet like have a cross-embodied model. So that that same model. So suppose you train a walking model or the locomotion policy for a humanoid, for a unitary humanoid, which is a very famous company for robotics now. So unitary humanoid model can be deployed across your humanoid. So if you build your humanoid, you can directly take that foundation model of that locomotion and give it, put it on your humanoid robot, and it should walk just like the unitary robot is walking. So that's the goal that we are trying to achieve, but not yet achieved fully. But yeah, that's the road that we are on, the roadmap we are on.
So when you say that you build those simulations, it's computer simulations, right? Based on certain vectors, drone images, coordinates, and all that. Is that correct?
Yeah, there are so many low level libraries. We bring on the neural reconstruction of the world, of the actual digital spaces into the digital world of Omniverse. The software we use is the Omniverse, which has the physics engine, so which can photorealistically emulate with the ray tracing cores of NVIDIA GPUs, can directly create the neural rendering of those actual spatial coordinates XYZ, not only XY. So right now you can bring those into the digital world, and then through those XYZ coordinates you can map your robot where they are.
So far, let me ask you a theoretical question, right? So far, what is the success rate for such models where you are, let's say, deploying a humanoid to tackle all those, like, for example, on an Indian street where there are lots of gullies and mohallas and traffic and no, let's say the rules are not that stringent where people are going left, right, and center. In such a
Right.
scenario, right? So how do you is there a plan to tackle all those kinds of things, or do you already have something that is working on such kind of a scenario?
So, nice question. So, India is a very diverse data set. At NVIDIA, we speak humorously that we have certain need of synthetic data to train these kind of robots. And in India, you can find a lot of scenarios, corner use cases where these kind of robots actually can crash anytime. So, for building diverse data set, India is the best country. But right now, so as I said, there are two kinds of physical AI aspects: outside in AI and inside out AI. So the simulation part is the inside out AI, but outside in AI is something like from the cameras, you bring the data into the robot brain and then analyze what is the, like, suppose some accident happened in another room, then the robot will be aware through the warehouse cameras, CCTV cameras or the RTSP cameras, that some accidents happened in the room number 2 and I need to go and check there. So inside those warehouses in a controlled environment, yes, we have deployed a large number of robots in India warehouses as well. But coming to farms and all these all-terrain robots, India is still behind that because mainly because of the civic sense, I would say, because in UK, there are a lot of all-terrain robots that we have worked on and deployed, and they don't steal the robots or destroy them. Rather, they and like feel good that they have the robots walking among them. But in India, I think there's a very challenging task to make the autonomous robots walking in the streets, because these are very much costly affairs and we don't want the robots to be stolen and destroyed. So that's why in a controlled environment like warehouses and factory floors, we have deployed all these robots, but we have not tested like drones again, and in a controlled environment in forest, reserved forests, but not in general public areas.
To watch the full conversation, click on the link in the comments below.